Hello Algebra 1B. This video is going to be on how you factor perfect square quadratics. Because factoring and distributing are so much related, I want to start off with this distribution problem to get us in the factoring mindset. If you're feeling good about it, pause the video, try it on your own. Otherwise, we can go through it together. So looking at this first problem here, if we wanted to distribute this, we usually break it down into two parts. Distributing your x with these two terms, and then distributing your negative 10 with these two terms. So starting with the x, I would say x times x is x squared, and x times the 10 gives you 10x. Then we could do the same thing with that minus 10. I could say negative 10 times x is negative 10x, and negative 10 times 10 gives us negative 100. Now with these problems, we're usually not done. There's usually something else you can do to simplify. Looking at this problem, I noticed these two terms here in the middle. They have the same variable and the same exponent, not like this one. And so because they have the same variable, same exponent, we can combine them. When I go to do that, 10 minus 10 is 0, so I'm left with 0x, or 0, which is nothing. So in other words, those two terms cancel out, and I'm just left with x squared minus 100. Now I picked this problem in particular because there's something special about this problem, and that's what happened right here in the middle. Lots of times with these problems, they don't cancel out in the middle. You're left with some number with your x, but in this problem, they canceled out. Think about why they canceled out. Like, why does 10x minus 10x cancel? Well, when we think about what it means to cancel, it means you're getting 0. So the reason these canceled is because a positive 10 and a negative 10 make 0. When we come back up to that original problem, we've got a negative 10 and a positive 10, which would combine to give us 0. Now the reason I'm starting off with this is because what we're doing in these notes is very similar to this, but going in the opposite order. So in these problems today, I'm going to be giving you something like this, and you're going to be trying to go up to a problem like that with the two parentheses. Now in the past, what we've done when we were trying to factor a quadratic is we would think about all the different combinations of numbers that multiply to give you 100. Oftentimes we would come over to the side, make a list. I'd say 1 times 100, 2 times 50, 4 times 25. And for 100, that list is going to go on and on and on for quite a while. But we instead can make this a whole lot easier and use that special thing about this problem. Because these two canceled out in the middle, I only have two terms. When you see that middle term is missing, that's going to let you know when it goes to factor, it's going to look like this. You can also think of it as that middle term equaled 0. That's why it's missing. So we need to pick two numbers that are the same with different signs to make that 0. The easiest way to figure out what that number is just taking the square root of 100. What all of these problems are going to have in common is that number we're given is going to have a square root. That is why all of these are called perfect squares, because 100 is a perfect square because 10 times 10 gives you 100. That makes this a lot easier because I don't have to write all the factors of 10 down here. I know, because that middle term is missing, that just like all the other problems we've been doing, we're going to have x times x to make that x squared. But instead of thinking all those different combinations that multiply to give you 100, because there's no middle term missing, I know it's just going to need to be 10 and 10, and I would need a plus and a minus sign so that they multiply to give me a negative 100, and so that those numbers combine to give me 0. Because remember that x is missing because it's really 0x. There are 0 x's in this problem. Notice that's also what we started with up here. Actually, it isn't exactly what we started up there, which is a good point. Notice up here I have x minus 10, x plus 10, and down here I wrote x plus 10, x minus 10. This is just like a good opportunity to say it doesn't matter the order you write these parentheses in, right? If you just think about numbers, like 10 times negative 10, that's the same thing as negative 10 times 10. The order you write things with multiplication doesn't matter. So same thing with these polynomials, is it doesn't matter the order you put those two parentheses. To help us practice with this a little bit more, I'm going to make up Let's do 2 more problems. So moving away from the distribution into factoring. If I asked you to factor x squared minus, let's do 49, and let's do s squared minus 64. If you're feeling better about these problems, feel free to pause the video now and try them. Otherwise, I think I'll talk through this first one and then we'll have you all try this at home. Again, the first thing I notice is it looks different than the ones in the previous set of notes, right? I only have 2 terms. I don't have an x. If it really helps you, you can always think of these as plus 0x minus 49. But the easiest thing is if that middle term is missing like that, what we want to do is think of what the square root of 49 is. What pair of numbers is going to multiply to give me 49 and combine to give me that 0? And so when you think about the square root of 49, that number is 7. And then we can fill in those signs with plus or minus. I always am going to need 1 positive and 1 negative so that these numbers combine to give you that 0 and so that they multiply to give you the 49. Now something you can do for all of these, you probably already know what it is at home because you know how much I love doing it, is we can check, right? You can check this by multiplying out this problem. And every single time you're factoring, you're going to be able to check by multiplying out this problem because it always should equal what you're starting with. Remember, when you factor something, you're not changing what it says. You're not changing what the amount it represents. You're just changing the way it looks. Kind of like when we simplify fractions. It's just like a different way to express it. So I could check this by multiplying all this out and making sure it equals what we started with. If I were to do that, x times x gives us x squared. X times that negative 7 is going to give me negative 7x. And then we can distribute again with this 7. So 7 times x, positive 7x. And then 7 times my negative 7 gives me negative 49. Just like with that first problem, these are going to cancel out. And you're left with x squared minus 49. So if for any of these factoring problems, today's lesson, yesterday's lesson, future factoring lessons, because you're doing this at home, it's really hard to know you're doing it right. But what I love about factoring is you're able to check every single one of these. If you've got the right answer, you should be able to multiply it out and see that it represents, that your answer represents the same thing that was in the problem. So keeping that in mind, go ahead, pause the video now, try this one. You can check your answer too if you want, and then come back to see what the answer looks like. All right, I'm guessing you have an answer. That answer, just like the previous one, is going to have s and s to multiply to give you that s squared. And then all you have to do is think about the square root of 64, which would be 8. And then, doesn't matter the order, but one would need to be plus, and then one would need to be a minus sign. Now, the only other thing we can do with these is, see how I was starting off by saying, I know it's going to, you can't see anything. Ha. Now you can. See how I started off by saying, well, I know s times s is going to give me the s squared. I could change this problem just a little bit by giving you something like 25s squared minus 64. Now it's real similar to everything we've been talking about with that middle term is missing. There's a trick you can use to help you factor it out. If you are up for a challenge, pause the video now, see if you can figure out what this would look like when you factor it. Worst case scenario is you don't know, right? But give it a try, especially since you know how to check these. Did you try? Are you back? If you tried, maybe you figured out what the trick is. The trick is going to be using that same logic that you used for those first problems. Just like we are thinking about the square root of 64 to figure out that this needs to be an 8, when we go to do our s's, I'm going to think about the square root of 25 and know that it needs to be 5s and 5s. And then same as always, we need a plus and a minus sign. Now, if you were guessing something like this, I would highly recommend, we could check it by distributing it all out. 5s times 5s gives you that 25s squared we were looking for. The 5s times that minus 8 gives you minus 40s. Here we get, I'm going to run out of room, the positive 40s. And then the 8 times the negative 8 gives you that minus 64. Just like with those previous problems, because we kept all the numbers the same, that gives us the same number here, the minus 40, the plus 40. So those cancel out, and we're left with that 25s squared minus 64. Now that idea of keeping all of these numbers the same so that these give you the same number to cancel out is really important. I've seen students say, well, what if I had put like 25, whoops, that's a 21, 25s and 1s, or just s, right? That would also multiply to give me 25s squared. This would also multiply to give me negative 64. Could it be this? Well, if you were asking me that in class, guess what I would ask? I would probably say, well, how could you figure out if that was the answer? And the answer is checking. If we were to multiply all this out, you're going to see that, yeah, when you multiply these together, we get that 25s squared that we want. Now, don't forget, you would also have to multiply these here. 25 times 8 is going to be negative 200s. The problem's going to be when you go to distribute your 8, that 8 times 1s is going to give you plus 8s. Now I could keep going, but we're going to see these aren't going to cancel out like in that previous problem. So the reason we've said that there's like a trick for these, right? You don't have to list out all the factors of all the numbers because it's always going to have to be the same number. You can't have different numbers like this because then when you go to distribute, they're not going to cancel out, leaving that missing middle term there. So to finish up this video, I'm going to write one last problem on the board. You want to try it at home, pause the video, make sure you've gotten it before you go on to that homework. I'm going to have you go ahead for me and factor, let's do 16y squared minus 121. And go. And you're back. So when you go to factor this, we know there's going to be 2 sets of parentheses because it is a quadratic. For that first part of each parentheses, we know it's going to need to have that y to get the y squared. And then if I'm thinking about the square root of 16, it would need to be 4y and 4y. Same thing for the 121. The square root of 121 is 11. So it would end up being something like 4y minus 11, 4y plus 11. Obviously, you would always want to check. And when you multiply it out, you get 16y squared plus 44y minus 44y. That should start making you happy because we see they're going to cancel. And then that last part, minus 121. So we see those cancel, and we're left with exactly what we started with. Now, with all these checking parts to the problem, just make sure at the end, like, you know what that final answer is, because I've got a lot of math written here on the board. Which line is the answer for the question, factor the expression? Which one shows factoring? That's going to be this right here. Remember, factoring means changing something to look like multiplication. This is your answer. This is the check. Don't write this for an answer because all you're doing then is copying down the problem. I only say this because some students have done this before. Hopefully you found that this video was helpful. I miss you all. If you haven't signed up for a student conference already, this is me advertising. Please do it because they're happening this week. And obviously I love seeing all your all's faces, and I miss you all so much. So I hope you're doing well at home, and have a nice evening. Bye.